All right. So our first lesson for this semester is data analysis with Excel. This is basically a review of what we did last semester. And then we're going to learn how to do what is known as weighted linear regression. Okay. So here's the handout for this lab, data analysis with Excel. So there's a computer lab activity here for weighted linear regression. Um, First of all, let's just review how we can do data analysis with Excel. So here's a template. If you open this. So click on this one. It will open in Google Drive, but you have to download it to an Excel file. Okay, so File, Download, Microsoft Excel. And once you have downloaded it, you can open it. And then you can close this one right here. So here's the Excel file. Enable editing. Oops, sorry. Enable editing. And you'll notice this is the same sheets we worked on last semester. So here's a stats template. Generally you'll be doing several trials for your experiments this semester. And so if you have multiple trials, you need to be able to get statistics for those. Okay, so here in this example, okay, let me just change this to 0.150, take out the asterisk there, give me an extra decimal place there. Okay. So how do we get statistics for our data? Okay. I think I intended this to be, sorry, 1.150. I'm gonna put an asterisk there because my intention there is to reject that. So if you recall from last semester, you can do a Q-test. Okay, so let's just pretend that that is to be rejected. So you can actually do that Q-test over here. So that 0.15, the lowest possible of the 10 trials, is based on the Q-test statistics can be rejected. So this is the same sheet you created last semester. So this you can just use this for this semester. Okay. So how do you get stats for your data? Let's say you're rejecting data point number 2 here. So I'm just putting an asterisk there that makes it not a number as far as Excel is concerned. So it will only count. If you count the number of entries here, it will only count entries that are numbers. So what would be our formula for this one right here? We're going to say this is going to be equal to count, open parenthesis, and then highlight these numbers right here. So we're hardly ever going to do more than 5 or 6 trials. So this template should be good enough for pretty much what you do this semester. Notice it's only counting 9 data points. Okay. If I did not reject that, if I kept that as is, then you'll see that you got 10 data points. All right. And let's say you deleted the last 2 data points. You can see you would only have 7 data points. You have 8 and then 1 here to be rejected. So you'll have just 7. Okay. So let me just undo what I just did. So I have 9 data points. How do you get the average of all of these? You just type equals average, that the mean of the trials, just highlight everything. Okay, and you get an average of 0.183. It doesn't matter that it ignores, basically, it's gonna ignore that 0.150 right there because it's not treated as a number. How do you get standard deviation? You say equals STDEV, open parenthesis, and highlight everything. Okay, so that's 0.004. Now, standard deviation and anything related to standard deviation, if you recall, are just different ways for us to express the uncertainty or the precision of our measurement. So generally, as a rule, we keep one digit past the first non-zero digit. So you adjust the format for this one. You're gonna go increase the decimal place because you want to go one decimal past the first non-zero digit. So this is going to be expected of you for all your reports this semester. Okay. So standard deviation of the mean, how do you get standard deviation of the mean? That's going to be square root of, I'm sorry, it's going to be whatever the standard deviation is divided by the square root of the number of trials, which is going to be this one right here. And that's 0.001. And just like the standard deviation, you want to report that to one extra digit past the first non-zero digit. Okay. Confidence level, you can select different confidence levels to specify confidence interval. For our purposes, in this class, we're just going to take 95% confidence. So we just pick 0.95. And how do you get the t statistic? You type equals TINV, T inverse. Probability is the 1 minus the confidence level. Let's see. 1 minus the confidence level. Is it? And then the degrees of freedom is n minus 1. Right? So 2.306 is your t statistic. And then your confidence interval will just be equal to t times standard deviation. This is the confidence interval for a single value. And again, we're going to put an extra digit there, past the first non-zero digit. Confidence interval of the mean is just equal to whatever the t statistic is times the standard deviation of the mean. Okay. And so that's going to be 0.003. And then we go one decimal place past the first non-zero digit. Okay. Now let's pretend that the true value is 0.180. Okay, so our average for our trial is 0.183. Our true value is 0.180. The absolute error is just going to be equal to the average, which is our best estimate of whatever it is we're trying to measure. This is the average of the multiple trials minus our true value, which in this case is 0.180. Okay, and our relative error is just equal to absolute error divided by the true value. So that's relative, how the absolute error compares to the true value. And this is already formatted to show it in percent. And you can adjust number of decimal places. Generally, two sig figs for relative error should be sufficient. Okay. So when you do statistical information for multiple trials, then you're gonna have to do this, use this template. This would be good. This would be a quick way to get your results analyzed. All right, so that's how you do analysis, statistical analysis of your trials. Okay, and as I mentioned earlier, Q-test, this is where you would enter your data, and this is the Q-test for potential outlier is the minimum. Okay, so you should remember how to use this from last semester. So keep a copy of this in your computer so you can modify it as needed for the semester. All right. Now, in this sheet, file, we also have the linear regression template, which we're going to use now for what we're going to talk about today, which is weighted linear regression. Okay. So I am going to stop the recording for now and pause. So if you can ask questions if you need to, and gives you time to get caught up as well.